Now that you understand the steps needed to download a program, which you learned by downloading a sample program, let's take a step back and figure out what all this code is really doing. Here on the main screen, we have several lines of code. Let's walk through what each of these commands do. The first line contains the command task main. This line creates a task called main, which contains the behaviors that we want the robot to do. If you look on the next and last lines, there are braces. Braces create structure for a task or function. In this case, it's task main. The code that falls within these braces tells the robot what to do sequentially. As you know, the code currently tells the robot to move in a circle. More specifically, it tells the robot to move motor port 3 forward for 3 seconds. Turning only one motor, or wheel, makes your robot move in circles. The line motor, bracket, port 3, end bracket, equals 127 tells the robot to move the motor on port 3 full power forward. Every statement must end with a semicolon. The next line sets a wait state. The command wait1msec is telling the robot to wait for a number of msecs or milliseconds. The number within the parentheses, 3000, is equal to 3 seconds, so the robot moves for 3 seconds. Right now, our robot moves in a circle for 3 seconds. We want it to move forward for 3 seconds. Before we make any changes, let's save this program with a new name. Go to File, Save As, and rename this program to Labyrinth. Add a new line after the first motor command, but before the wait statement. In order to make the robot go forward, you'll want both motor port 2 and motor port 3 to move forward. Begin with the word motor. The motor that the command is directed to is indicated inside of square brackets. Type the brackets in the motor name just like the line above, but specify port 2 instead. Set it equal to 127 for full motor power in the forward direction. Make sure your robot is turned on and connected, and go to Robot, Compile and Download. Once the program is finished downloading, move the robot to the maze and press the Start button on the Program Debug window to run it. Well, that didn't quite work, did it? If you take a closer look at the bottom of your robot, you'll notice that the motors are mirrored images of one another. This symmetry causes the rotating shafts of the motors to be facing in opposite directions. So even though the motors are set exactly the same within Robot C, the motor connected to port 2 rotates in the opposite direction and causes the robot to spin. In this lesson, you learn the different parts of the program, how to add your own motor commands, and why the robot continues to spin even though port 2 is set to full power forward. Move on to the next lesson to solve the problem using the Motors and Sensors Setup window.